Hi, welcome back to Imperium Learning. In the previous video I introduced the topic of the speed of adjustment and how you calculate it, and how it's an important point to include when you're analyzing your vector error correction model. I've actually just calculated a table here for the speed of adjustment. So in case you didn't see the previous video, I ended on this slide which tells you how to calculate the speed of adjustment. It's calculated by multiplying the coefficient of the variable in the co-integration equation by the coefficient of the error correction term, where the first difference of that variable is the dependent variable. So what does that mean? In practice, well, ln AHP 1 times by minus 0.1808 and notice here how ln AHP is the dependent variable, so you multiply those two together and we get a percentage of minus 0.1808. ln M4, or the money supply, minus 0.2561 minus 0.2561 multiplied by minus 0.0156, and that gives you 0.004. Ln credit, and I'm not going to go through it. Hopefully you can understand where I'm coming from. So what do we these are important because what we do then is we convert these into percentages. So minus 0.18, that's like 18%. 0.004, that's like 0.4%. minus 0.0643, that's like 6.4%. 0.074, that's like 7.5% actually, because you're rounding up, and then the final one is like 0.5%. So what we want is the speed of adjustment to be at least minus 0.05 or less. So in other words, more negative. So like say minus 0.1 is more negative than minus 0.05. So if we go back to here, we can see that one there, that one minus 0.18 is really good. Now this is the really questionable one, my money supply, because that's got a positive coefficient. So what does that mean? Well, it's concerning if your speed of adjustment products are positive, like say for my money supply, because that means that your VECM continues to move away from the long run equilibrium after experiencing a shock instead of converging back to it. But the most important one is obviously your dependent variable. I was very happy with my dependent variable being converging back 18% in one time period. Obviously these are statistically significant as well at the 5% level, because obviously they're less than minus 0.05. The same for the interest rate. This has the right sign, but it's not statistically significant at the 5% level. But the money supply, when we're talking about the speed of adjustment, my speed of adjustment, it was the most problematic for the money supply. So yeah, and also when you talk about your vector error correction model, you can just make a brief comment about the R² value. So if we go on Eviews and we scroll all the way down, you can see it's right there for my ln AHP variable. So yeah, so what you should be doing, bear in mind when you're analysing your vector error correction model. So we need to analyse the sign. Let's just go back to the table. The sign is negative. Then you need to look at the magnitude. In other words, is it less than minus 0.05? And then the final thing is the significance, so at least 5%. So in other words, if we want it to be statistically significant, we want something that's below 0. We want something that's more negative than minus 0.05. So this ticks the box, that ticks the box, that ticks the box. That's the wrong sign, but it's also statistically insignificant, so that's not as bad. This one's the right sign, but unfortunately it's not statistically significant because it's not more negative than minus 0.05. So those are points that you should be addressing when you're analysing your the results of your vector error correction model. If you do have mixed results, try to improve them by improving the specification of your model. If that's beyond your abilities and your teachers can't help you out, then just stick with what you've got and just show your understanding of your model by criticizing it and trying to find a reason for why you might have problematic results. So in my example, I had a lot of structural breaks in my variables. My loan credit, my interest rate, and my unemployment all had 2 structural breaks in them, and the break dates were at different points, and so it was very difficult to try and estimate dummy variables that would account for all these various variables because of their differing break dates. So it was very complicated, and so I think as a result the best course of action was just to carry on with the results that I have. So that wraps up what turned out to be a 5 video series on estimating a vector error correction model, and also how to interpret the results and analyze them for the purposes of an essay. I really hope that this video series helps you, and if you think it's good content, don't hesitate to subscribe and thumbs up. It could help other people out there on the internet who are struggling. So yeah, I think I'll wrap up the video now. Okay, bye now.